Hi class, let's talk about the last scenario in terms of predictions for chapter 3. So this is the idea. If you know that the data set is bell-shaped, you're going to use the empirical rule, and then those three standard deviations are actually standard. Now, if we don't know the shape of the distribution, or we're not actually sure, then in that case, Chebyshev's theorem is the most appropriate one to use. The moment that they mention that it may not be bell-shaped or approximately bell-shaped. Now, Chebyshev's theorem says the following. And you technically can apply it to any distribution, but if you already know that it's bell-shaped, apply the empirical rule. Now, and this is what it says. Any set or distributions is going to be called K, and if you know that the data is not bell-shaped, this is the formula that you're going to be using for percentage of data. If they want intervals, you're still talking about mu plus or minus K, and then K is given as 1, 2, 3, 4, 5. Technically, any value K greater than 1, so you could have 100 standard deviations. You're not limited to 3. So if you remember the empirical rule, because the data was perfectly bell-shaped, we only went up to 3 standard deviations. Within 3, you had 99.7% of data. So not necessarily true on Chebyshev's theorem the moment that they mentioned that that is not bell-shaped. And then for unusual scores, any value outside of the upper and lower fence, the upper and lower fence is evaluated with that formula. You assume that the IQR is Q3 minus Q1. So let's take a look at the last example. And in the last example, they're basically talking about prices of gasoline. And let me just highlight what we need, or let me write down what we need. Okay, so you have that the average, or in this case, mu is equal to 3.64, and you have a standard deviation of, so we have sigma to be technically 0.04. So those are the values that we're going to be using, and then the most important part is that it's not bell-shaped. Now, they want what percentage of data is within 3 standard deviations away from the mean. So in this case, this is K. So for K is equal to 3, the proper formula to use is 1 minus 1 over K squared. So in this case, 1 minus 1 over 3 to the second. Please evaluate that. I'm getting that this is approximately, so this is supposed to be a 3. 88.89% of data. Now, they want the interval. So your intervals are actually done the same. You're still going to have that mu plus or minus 3 sigma. And in this case, mu is 3.64. So 3.64 plus or minus 3 times 0.04. Please evaluate that interval. So you're looking at the interval of 3.52 to 3.76. So this is what we're talking about in terms of actual, and then the units, we're talking about prices. So in this case, that's going to be money-wise. Now, your proper sentence, in this case, it's going to actually have to include the Chebyshev's theorem idea. So Chebyshev's theorem comes with an at least statement, and this at least statement happens to be with the 88. So 88.89% of data within a total of 3 standard deviations above and below the mean. and then technically the price is 3.52 to 3.76, and we're talking about technically money. You can put the money symbol inside or on the outside as long as you actually include it. And let me double check the intervals. 364, 352, and 376. So that would be our final answer. The solution that we're providing sounds similar to what we did on the previous one, except that in this case we're talking about a different theorem, since technically they're telling us that the data may not be bell-shaped. Let's talk about B. Now you're gonna notice something different on this particular scenario, and that's that you're not going 1, 2, and 3 like with the empirical rule. They actually want 2.5. So they want the same percentage of data, and then technically, well, the prices. So in this case, well, for the values of k, this is equal to 2.5. So k is equal to 2.5. The percentage, it's actually going to be 1 minus 1 over 2.5 squared, which is approximately I'm getting 0.84, or approximately 84%. Remember that this is going to be an at least statement. And then for the prices, well, we're just going to be evaluating, in this case, mu plus or minus, and this is 2.5. So careful, 2.5 sigma, which our value of the mean was 3.64. So 3.64 plus or minus 2.5 times 0.04. So we're using the mean. This is supposed to be a 64. So 3.64 okay, so let me give you the interval that I'm actually coming up with. So I'm getting 3.54 to 3.74, and technically that's gonna be our actual interval. Now our sentence, it's gonna be almost identical to the previous one. Keep in mind that you're still using, well, technically Chebyshev's theorem, and let me just cut and paste it so that it's faster. So by Chebyshev's theorem, we have at least, this one came out to be 84 percentage of data within 2.5. So 2.5 standard deviations above and below the mean. The price ended up being 3.54 to 3.74. That's going to be our final answer for this particular one. So let's take a look at part C. And in part C, they're asking for the minimum percentage that's within the interval. So technically, this is your interval. And the lower bound, it's going to represent mu minus k sigma. And the upper bound is going to be mu plus k sigma. Now, you couldn't really do what we did on the previous problem, which was guess 1, 2, and 3. For all of these problems, unfortunately, you're going to have to use algebra. Now, you're going to use algebra with the upper bound. And it is assumed that they're symmetrical because technically k can be any value. So you would have to actually solve the following. So this is mu plus basically k sigma. It's going to be equal to 3.74. So let me rewrite it as 3.74. The values of mu, we said that was 3.64. Let me just double check. 3.64. So 3.64 plus the values of k times 0.04. This is equal to 3.74. And technically, let me just double check. It is 0.04. Oh, we're good. Okay, so as we're solving this one, well, I'm going to start by subtracting, in this case, minus 3.64 minus 3.64, and that's going to give us the equation of, well, 0.04k. This is equal to 3.74 minus 3.64, and then we're going to be dividing by 0.04, and then make sure that you are not evaluating this one until the very end to avoid rounding errors. So which means that the values of k is equal to 3.74 minus 3.64 divided by 0.04. So please evaluate that. So please check it. I'm getting 2.5. So this particular one seemed familiar, but it's actually the previous one. So in this case, we found out that k is equal to 2.5. That's our final answer for the k. And we actually already calculated that for 2.5, you end up with 84% of the data. And in this case, our answer is going to be almost identical to the previous one. We do have to state the minimum percentage. So let me just obtain the previous answer. So we end up with exactly the same answer, except that you have to mention the minimum percentage. So you would just say that the minimum percentage is 84%. So the minimum percentage is 84%. And that's it. That would be it for Chebyshev's theorem. Let me just guide you on part D, and it's talking about unusual. So in part D, because it mentions unusual, in this data it's not bell shape, you're gonna have to use, well, Q1, Q2, and Q3, and then you're not gonna do 2 standard deviations above or below the mean. You're actually gonna use the following formula. So you would be using the fences. If the calculation that you obtain after the lower and upper bound happens to be inside of the lower and upper fence, then they're usual scores. If it's outside, it's unusual. And only for, data set that is bell shape, you're looking at 2 standard deviations above or below the mean.